is the most dangerous spot. There are lots of small rocks falling and very close to the surface. So that's the holy Mount Kailash.
Mount Kailash has long been shrouded in mystery, revered by millions and largely unexplored by modern science until now. What if satellite data has revealed something unexpected and truly baffling around this sacred peak? This discovery challenges what we thought we knew about one of the world's most remote and enigmatic places. Could these strange signals or formations unlock secrets hidden for centuries? As scientists sift through the puzzling evidence, questions arise about nature, geography, and possibly something beyond. The story behind this discovery pushes the boundaries of exploration in the 21st century. Unexpected satellite findings. Satellite data has long been a powerful tool for discovering hidden features on Earth, but few places spark as much intrigue as the region around Mount Kailash. Recent analyses revealed unusual patterns that defy easy explanation, located in the rugged terrain encircling this majestic peak. These anomalies caught the attention of researchers because they stand out sharply against the natural landscape, suggesting the presence of formations or phenomena not previously documented. The satellite images show shapes and structures that do not resemble ordinary geological formations found in high-altitude mountainous regions. Their distinct signatures prompted scientists to wonder if natural processes alone could have created them, or if other factors might be at play. What makes these findings so compelling is their consistency across different passes and sensors, reducing the likelihood that they are simple errors or glitches. Investigators detected variations in surface texture and reflectivity, indicating materials or features in places that traditional mountain mapping had overlooked. Even more puzzling are certain signals that hint at geometric precision, lines and angles uncommon in nature, but familiar in human construction or unknown natural phenomena. However, the area's extreme remoteness and difficult terrain have so far prevented direct ground verification of these claims. Because such satellite anomalies are rare and difficult to interpret, they immediately sparked a mix of excitement and skepticism within the scientific community. Researchers emphasize caution, noting that unusual satellite data often require corroboration from multiple sources before conclusions can be drawn. Still, the discovery near Mount Kailash stands out because of the region's unique environment and cultural significance, forcing a closer look at the implications. Some theories propose that the strange satellite signatures could arise from previously unseen geological formations, like rare mineral deposits or unusual rock structures shaped by millennia of shifts in the Earth's crust. Others speculate that subtle climate or weather-related effects might cause anomalies in reflectivity or temperature readings captured by satellites. Whatever the cause, the discovery invites us to reconsider how much remains unknown, even in some of Earth's best-mapped places. The findings have also intensified questions about what lies hidden in remote mountain landscapes, areas often unreachable except by the bravest explorers. Mount Kailash's inaccessibility has historically limited ground studies, so satellites provide one of the few windows into its mysteries. Yet satellite interpretation can be tricky, blending science and conjecture when signals don't fit neatly into established models. This confluence of unexplained satellite data and the geographic complexity of the region transforms a simple observation into an open puzzle. Researchers remain split between cautious optimism that these discoveries might deepen our understanding of Earth's geology and a reserved outlook warning against jumping to conclusions. As the story unfolds, the challenge will be to piece together available evidence without losing sight of scientific rigor. While scientists work to unravel these clues, they face a compelling question. Could this be just the beginning of a new era of discovery around Mount Kailash? The satellite data encourages us to look closer, reminding us that even now, remote corners of our planet hold secrets waiting to be revealed. The mystery of these satellite findings invites a deeper dive into the very place they emanate from, a mountain revered both for its natural grandeur and spiritual significance. Geographic and cultural significance. Mount Kailash, rising nearly 7,000 meters above sea level, is one of the most iconic and sacred mountains on Earth. Located in the western Himalayas within the Tibet Autonomous Region of China, it serves as the source of several major rivers feeding millions downstream. Its significance transcends geography. It is considered a holy site by Hinduism, Buddhism, Jainism, and the indigenous Bon religion, making it a unique spiritual crossroads. The mountain's striking symmetrical peak has made it a symbol of cosmic order and divine presence in multiple religious traditions. For millions of pilgrims, circumambulating Mount Kailash is a profound act of devotion, believed to bring spiritual merit and purification. Despite being relatively modest in height compared to nearby Himalayan giants, Kailash's unrivaled religious status elevates its presence in human history and culture. Accessibility is limited by its harsh environment, high altitude, and Chinese government regulations, which preserve its sanctity by restricting summit attempts. This means that while Western mountaineers often seek to conquer the tallest peaks, no one has officially climbed Mount Kailash. This spiritual protection adds to the mountain's aura of mystery, making scientific inquiry more difficult but culturally sensitive. Geographically, the mountain sort of sits at a junction between tectonic activity and climatic forces, and it ends up with this complicated geological setting. It's part of the Trans-Himalaya range, with sedimentary and metamorphic rock as the main ingredients. Then it was, and is, shaped by the collision between the Indian and Eurasian plates. So that combo naturally leads to varied rock formations and pretty lively geological processes, which could account for some odd satellite observations, but only in a limited way, not as a full answer. Culturally, Mount Kailash's sanctity has meant that surveys and explorations are usually done with a kind of deep respect for local beliefs, even when scientists really want specifics. Any archaeological or environmental studies have to move through this delicate balance, rarely approaching with methods that might disturb traditional practices. Around it, there are pilgrimage routes and monasteries, and the natural story and human story get mixed together, almost inseparably. That mix of grand nature and spiritual meaning has for a long time fueled mystery and also speculation. People talk about hidden caves, sacred lakes, and passes that seem unexplored, and that legend keeps unfolding. Now satellite data adds a new, modern scene to the same old narrative. And when scientific inquiry touches this sacred place, it has to do so carefully, because the traditions there have basically protected it for centuries. So, really understanding Mount Kailash's physical context alongside its cultural one is crucial if you want to interpret what strange satellite data might mean. It's a location where natural science and spiritual beliefs overlap, so any discovery feels far more resonant than just a cold geographic observation. The reverence for Mount Kailash adds layers of meaning and complexity to the mystery, setting the stage for a closer look at how satellites peer into this sacred landscape. Satellite technology used. The unusual findings around Mount Kailash owe much to the advancements in satellite remote sensing technology.
There is a substantial processing required for satellite measurements, not only to convert satellite remote sensing radiance measurements to geophysical values using algorithms, but also to visualize data as imagery,
which allows us to observe Earth with unprecedented detail and precision. Various types of satellites orbit the planet, equipped with sensors that capture different kinds of data, from optical images to radar, thermal, and hyperspectral readings. Each offers a unique perspective on surface features and environmental conditions. Optical satellites like those in the Landsat series capture high-resolution images visible to the human eye, which researchers use to map landscapes, identify vegetation, and track changes over time. Meanwhile, synthetic aperture radar (SAR) satellites can penetrate cloud cover and provide detailed topographic information by bouncing radio waves off the ground. This capability is invaluable in regions like Mount Kailash, where weather and terrain often obscure direct observation. Thermal sensors detect variations in heat emitted from Earth's surface, revealing temperature differences that can hint at geothermal activity or unusual mineral compositions. Hyperspectral imaging goes even further by capturing light across hundreds of spectral bands, allowing scientists to analyze surface materials' chemical properties. Combined, these technologies create comprehensive datasets to decode complex environments. Satellites tasked with Earth observation often operate with repeat passes, enabling changes over time to be monitored. This temporal dimension helps distinguish between transient phenomena like snow cover or seasonal vegetation and more persistent anomalies, such as unexplained formations or structural regularities. It is by comparing data from multiple dates that the Mount Kailash anomaly stood out in recent analyses. The satellites that collect this data are handled by a bunch of space agencies like NASA, the European Space Agency, China's CNSA, and also private companies. Because of more international collaboration, access to these datasets got broader and research scope increased. But political sensitivities connected to Tibet can sometimes limit how much ground truthing is done and what gets shared, especially there. Reading satellite data is not just a simple thing. It takes sophisticated algorithms and expert review because raw images can bury subtle clues under noise and distortion.
Mount Kailash is the most mysterious mountain in the world. Reports of strange light shooting from the mountain ridge and sounds coming from the inside of the mountain have led many to think that it is actually...
Lately, breakthroughs in artificial intelligence and machine learning help scientists notice patterns that a person might overlook. In fact, these methods had a part in spotting those unusual signs around Mount Kailash, which then led to more investigation. Even so, satellite tech has limits that should be taken seriously. There are issues with resolution constraints, atmospheric interference, plus the whole mountain environment complexity that can obscure or reshape what the instruments see. So if anything looks strange, it really deserves careful interpretation and ideally backup from on-the-ground observations, though those are quite rare around Mount Kailash. Still, these satellite tools are basically the front edge of modern exploration, letting us catch sight of corners of the Earth that used to be inaccessible or just not visible. As the technology keeps improving, the hope is to uncover more secrets similar to what has appeared around Mount Kailash, kind of bridging remote sensing with deeper human understanding, even if it is still uneven. With the tools and methods in mind, the next step is to consider what natural processes might explain these puzzling signals in this extraordinary landscape. Possible natural explanations. When faced with unusual satellite data, scientists first seek natural explanations grounded in geology and environmental science. Mount Kailash sits in a geologically active region where tectonic movements have shaped the landscape over millions of years. The mountainous terrain, with steep slopes and varied rock types, creates conditions ripe for rare rock formations and erosion patterns that can appear striking on satellite imagery. One explanation for the anomalies could be the presence of mineral veins or deposits that reflect radar or light differently than surrounding materials. Certain minerals, like quartz or mica, have distinct spectral signatures that might show up as unexpected patches or lines in hyperspectral or thermal images. Mount Kailash's geological complexity could easily harbor such mineralogical surprises hidden beneath snow or vegetation. Glacial activity is another strong candidate for natural causes. The Himalayan glaciers are dynamic, carving valleys and depositing sediment in ways that sometimes form geometric patterns or unusual shapes visible from above. Seasonal snow cover and melt cycles can also change surface reflectivity, creating temporary effects that confuse satellite readings. These natural shifts could explain some of the strange signals without needing extraordinary hypotheses. Avalanches and landslides occur frequently in the region due to steep slopes and seismic activity. These events rearrange rocks and soil abruptly, sometimes forming terraces or ridges with angular geometries that might register as artificial structures on satellite sensors. Over time, repetitive avalanches could carve patterns that elude casual observation but stand out in detailed remote sensing data. Geothermal features such as hot springs or fumaroles can produce localized thermal anomalies. Although less common at high altitudes like Mount Kailash, any subtle heat emissions could distort thermal imaging and create signals unrelated to purely geological formations. These variations may hint at subsurface activity linked to plate tectonics beneath the mountain. Weather patterns, honestly, they matter a lot too. Stuff like clouds, snow pushed around by wind, and those frost cycles can change how the surface looks when satellites are watching. Every now and then, weird atmospheric conditions make reflections or shadows look odd in the satellite images, but once you get the basics, they end up being pretty ordinary explanations. Scientists, they still have to separate those sky effects from real ground features carefully. Even with all these likely natural causes, though, some geological signs around the region still bug experts. They show this level of order, like straight traces or symmetrical forms, that natural processes usually don't manage by themselves. So then it turns into a question: are these anomalies just rare geological coincidences, or is there something more intricate going on underneath? Remote sensing isn't perfect either, particularly in this kind of harsh and hard-to-reach terrain. Ground truthing, meaning the checking of satellite data via on-site inspections, is extremely difficult around Mount Kailash. Without direct exploration, any claims about natural origins for these anomalies stay unsure, and scientists end up weighing possibilities with extra care. Still, even with that caution, the mountain's environment has plenty of natural mechanisms that can generate a surprising variety of signals. It's a place shaped by time, climate, and tectonic forces in ways that still don't fully make sense. The real difficulty is pulling apart the natural patterns from anomalies that could maybe suggest something else entirely. The debate sparked by these natural possibilities is mirrored by the varied reactions of the scientific community, reflecting a range of perspectives on what the data truly means. Scientific reactions and debates. The strange satellite findings around Mount Kailash generated a spectrum of responses from the scientific community, from intrigue to skepticism. Many geologists and remote sensing specialists applauded the discovery for highlighting how much remains to be understood about remote mountain systems, but urged caution against sensational conclusions. They point out the risk of over-interpreting ambiguous data, reminding us that remote sensing is a powerful but indirect method. Some scientists emphasize that the Himalayan region is full of surprising geological patterns and anomalies due to its dramatic tectonic history, making any strange signals less mysterious in context. They suggest the satellite findings could represent rare but natural phenomena rather than anything extraordinary. This viewpoint underscores the importance of rigorous peer review and repeated measurements before drawing broad conclusions. On the other hand, a smaller group of researchers are fascinated by the geometric qualities hinted at in the data. They argue that the regularity of certain features calls for more attention, perhaps indicating unknown geological structures or even archaeological remnants related to ancient human activity or religious sites. While these ideas remain speculative, they have helped spur calls for multidisciplinary investigations. Remote sensing experts also debate the limitations of satellites detecting subtle features at such extreme altitudes under variable weather conditions. Some caution that sensor noise, resolution constraints, and viewing angles could create artifacts, false patterns mistaken for real anomalies. This alertness to methodological pitfalls helps prevent premature conclusions, but also complicates the search for definitive answers. Geophysicists weigh in by proposing models of subsurface structures that might produce surface signatures visible from space. They consider how faults, fractures, and underground water flows could generate irregular surface thermal or reflective patterns. These models add scientific depth, but also show how many variables can affect remote sensing signals in mountainous terrains. Several scientific teams call for coordinated efforts to corroborate satellite data with ground-based measurements. However, accessing Mount Kailash remains challenging due to its ruggedness and religious restrictions. This practical limitation fuels ongoing debate about how and when these anomalies might be explored more directly without infringing on local sensitivities. The intrigue surrounding the findings has also led some researchers to discuss the broader implications for Earth sciences. They consider that discoveries like this might redefine what we know about mountain formation, mineral distribution, and even climate interaction on alpine scales. The unknowns highlighted by these satellites remind scientists how much remains uncharted in the natural world. Despite the spirited debate, all agree on the need for transparent, careful analysis and open sharing of data. The collaborative nature of modern science means that new discoveries must undergo thorough scrutiny and testing before acceptance. This process may be slow when dealing with such remote and sacred sites, but ensures credibility. As the scientific community wrestles with these questions, the legacy of Mount Kailash continues to inspire both curiosity and respect, prompting a closer look at how emerging technologies can illuminate ancient mysteries. Each new perspective adds another piece to an evolving scientific conversation, where skepticism and curiosity work side by side. Whether the anomalies ultimately prove ordinary or extraordinary, the debate itself advances knowledge, encouraging future generations of researchers to question assumptions, refine methods, and explore Earth's greatest mysteries with integrity. The unresolved nature of the debate naturally leads us to explore the fascinating historical and mythological context that colors every discovery near this sacred mountain. Historical and mythological context. Mount Kailash is not only a geological marvel, but a mountain steeped in rich spiritual and mythological significance that spans multiple ancient religions. For Hindus, it is regarded as the abode of Lord Shiva.
Mythology provides fascinating stories behind these. It is said that Rakshas Tal was created by Ravan, a devoted worshipper of Lord Shiva,
the supreme god who resides there in a state of eternal meditation. This sacred association has elevated Kailash to a place of profound reverence, where circumambulating the mountain is believed to cleanse one's sins and lead to spiritual liberation. In Buddhism, Mount Kailash is identified with Mount Meru, regarded as the center of the universe and the axis around which the cosmos revolves. Tibetan Buddhists view the mountain as a sacred site of immense power, part of pilgrimage practices that reflect devotion and respect for the natural world. The rituals and stories connected to Kailash have created a tapestry of meaning that transcends the physical mountain itself. Jainism also reveres Kailash as the site where its first spiritual teacher, Rishabhadeva, attained liberation. This deep historical importance makes the mountain a shared symbol of enlightenment across diverse faiths. The Bon religion, indigenous to Tibet, venerates Kailash as a sacred mountain containing powerful spiritual energy and views it as a source of mystical teachings. These layers of religious belief have led to countless legends that often describe supernatural or mysterious attributes of the mountain. Stories about hidden caves, divine beings, and unexplored realms are woven into local folklore, imbuing Kailash with an aura of mystery that captivates both believers and outsiders. These narratives suggest that the mountain may harbor more than just physical or geological secrets. Many ancient texts, and the oral traditions that orbit around them, stress that Kailash cannot be conquered or climbed because it is consecrated ground, kind of under a special kind of protection. So you get this veil of sacred safeguards, which sort of limits direct exploration and also keeps the mountain's mysterious aura intact. Respecting this spiritual boundary ends up mattering a lot for both modern research circles and the everyday local mindset in that same steady way. Some scholars have even floated the idea that unknown man-made structures or old constructions might be tucked somewhere near Kailash. Maybe they function as pieces of religious observatories, temples, or ritual sites that later faded out of memory. That idea seems to find a faint, almost whisper-like response in newer satellite data because it shows unusual shapes and formations that could, if you squint at them through history, line up with myth and old human stories. Still, there is no solid proof yet that those satellite indications actually connect to historical artifacts or spiritual architecture. Yet the symbolic context is what keeps the question alive. It pushes for a multidisciplinary conversation between archaeologists, historians, and scientists, and tries to balance careful measurements with cultural meaning. Not just data for data's sake, but data plus respect, you know. The spiritual and mythical layers around Mount Kailash remind us that this mountain is far more than a physical landmark. It reads like a living monument to belief, mystery, and reverence. Those elements, together, make any new discovery nearby feel even more intriguing and a bit unsettling too, in a good way. Whether viewed through the lens of faith, history, or science, Mount Kailash continues to stand as one of humanity's most compelling mysteries. Its enduring legacy reminds us that some places hold meaning beyond measurement, inviting every generation to seek understanding while honoring the traditions that have protected them for centuries. Bridging this ancient reverence with contemporary exploration leads naturally to consider what new scientific ventures might bring. Implications for future research. The strange signals detected around Mount Kailash open exciting possibilities for future scientific expeditions and satellite missions aimed at deepening our understanding of this enigmatic region. These findings could motivate more targeted remote sensing studies using higher-resolution instruments, potentially revealing finer details of the terrain and any unusual features within it. Advancements in sensor technology may soon allow clearer differentiation between geological and possibly artificial formations. On the ground, researchers hope to initiate multidisciplinary expeditions that combine geology, archaeology, and cultural expertise. While access remains challenging due to altitude and religious regulations, collaborations with local communities and authorities could enable respectful study that balances scientific goals with cultural preservation. Such efforts would aim to verify satellite data through direct observation and sampling, providing crucial context to remote findings. Emerging technologies like drones and autonomous exploration vehicles might also play a pivotal role, offering new ways to survey difficult areas without disturbing sensitive sites. These tools can gather high-resolution images and environmental data at close range, expanding the toolkit available for investigating the mountain without intrusive human presence. The expansion of international cooperation in satellite data sharing and analysis will enhance the global effort to monitor Kailash and similar remote areas. Open access to diverse satellite platforms increases the chance of catching transient or subtle phenomena that might otherwise go unnoticed. This collaborative framework encourages transparency and accelerates scientific progress. Further study might also look into the mineral wealth and the tectonic behavior under the ground.
Science also fails to account for the unique geology of Mount Kailash. While surrounding peaks in Tibet are made of sedimentary rock, Kailash is the only mountain in the region to be made from black rock, a raw material that is quite rare.
Using geophysical surveys alongside satellite watching, if we can grasp the mountain's inner workings, we may be able to explain what is driving the surface oddities and improve how Himalayan geology is understood. That matters not just for academic curiosity, but also for natural hazard monitoring plus environmental stewardship. Still, any upcoming efforts should respect the mountain's sacred standing and weave ethical concerns directly into the research layout. Many investigators are now very aware of the need to safeguard both the living landscape and cultural inheritance, so that scientific curiosity does not end up overriding spiritual meaning. Some educational and community outreach efforts could emerge from these findings, helping people notice why Mount Kailash is important in both scientific and cultural ways. By building conversations between researchers, spiritual authorities, and local residents, such work can foster a deeper understanding and encourage caretaking of this special terrain. As future research moves forward, it may not only reveal hidden puzzles, but also strengthen the ties between ancient insight and modern science. That kind of combined approach could become a template for exploring other sacred and isolated places across the globe. Ultimately, the drive to learn at Mount Kailash reflects humanity's long-time interest in our planet's wonders, combining advanced technology with real regard for long-standing tradition. Every new investigation has the potential to deepen not only scientific knowledge, but also our appreciation for places where nature, history, and belief converge. Whether future discoveries answer long-standing questions or reveal entirely new ones, Mount Kailash will continue inspiring exploration guided by curiosity, respect, collaboration, and enduring wonder for generations. The ongoing journey to decode this mountain's secrets invites us to consider the unending allure of the unknown and the promise of discovery still waiting high in the Himalayas. Mystery's ongoing puzzle. Despite advances in technology and extensive research, the mysteries surrounding Mount Kailash continue to challenge our understanding. The strange satellite data hint at secrets beneath the snow and rocky slopes that refuse simple explanations. This ongoing puzzle captivates scientists and explorers alike, reminding us that even in the modern age, certain places remain elusive and enigmatic. The interplay between natural processes and possible human influence complicates interpretations of the data. While many anomalies may result from complex geology or climate effects, the possibility of undiscovered artifacts or geological structures cannot be entirely dismissed. This uncertainty fuels both scientific inquiry and imagination, pushing experts to develop new tools and theories. Mount Kailash's remote location and cultural protections slow direct investigation, but also preserve its untouched character. This delicate balance between access and preservation creates a unique challenge for future research. Respecting local traditions while satisfying scientific curiosity requires collaboration, diplomacy, and patience. One enduring question is how much of the mountain's secrets are recorded in its landscape itself, whether through rare mineral configurations, ancient human markings, or other unknown phenomena. Satellite imagery has given us a tantalizing glimpse, but the full picture remains obscured by terrain, weather, and political boundaries. Each layer of data adds depth, but also complexity to the story. As technology evolves, artificial intelligence and improved remote sensing may allow better discrimination between natural and artificial features. Machine learning algorithms can analyze patterns invisible to the human eye, potentially unlocking new insights. These tools could revolutionize how we explore inaccessible or sacred sites around the world. The implications of trying to solve this mystery go well past Mount Kailash by itself. If we uncover unknown geological formations or even cultural artifacts, it might reframe how we think about Himalayan history and its evolution. And on top of that, it could feed into environmental monitoring, plus risk assessment, for an area already pretty vulnerable to climate change, and seismic activity too. What stands out in the current debate is the real value of going interdisciplinary, kinda mixing geology, archaeology, anthropology, and these newer kinds of tech. But only by working together, like genuinely collaborating, can the different sides of Mount Kailash's mystery start to come into sharper focus. This whole way of thinking, it also tries to keep respect for both science and tradition, not just one. So you get rational inquiry alongside cultural sensitivity without flattening it. Even while unanswered questions remain, the conversation started by these findings has already deepened our appreciation of how layered the mountain really is. It pushes experts and also enthusiasts to question old assumptions and treat the unknown as something useful, not like an obstacle. And there's this reminder too that science itself keeps evolving, and that we owe care to places with deep human meaning. Ultimately, the tale around Mount Kailash's satellite anomalies is far from finished. Every new observation feels like another small step toward revealing hidden truths, and it keeps alive that old exploration spirit that has drawn people to this sacred peak for millennia, really. Perhaps the greatest discovery will not be a buried structure or forgotten civilization, but a deeper understanding of why certain landscapes inspire enduring wonder. Mount Kailash continues to mystify us, blending natural wonder with spiritual depth and unexplained satellite signals. As we've seen, this remote mountain holds secrets that challenge both science and belief. If you enjoyed exploring this enigma with me, please like this video and subscribe for more intriguing stories from our mysterious world.